So in parts 1 and 2, we've tackled the basics of what probability is. We've tackled introduction, definitions, certain and impossible events. And then we moved on to tackle the really tricky issue of relative frequency and theoretical probability. Now, if you haven't watched those videos, I strongly recommend you go back now. So, I've called this section Basic Questions because at first glance they will appear quite straightforward. But then we're going to introduce a new rule off the bat, so don't give up just yet. Now I'm going to start with another set of beads that are trapped in a bag. So, what is the probability that a bead is red? Well, there are 5 red beads out of 7 beads in total. And remember to give your answer as a fraction, a decimal, or a percentage. Okay, seems over all right so far. The probability that a bead is black in this bag is 2/7. Now, when your denominator is 7 and 1/7 is a really tricky decimal, in fact it's a recurring decimal, so its percentage is quite complicated, you're going to say to yourself, stick to fractions. And that's a good idea. So let's take it one further. What's the probability that I roll a 6 on a die? And I'll say die because it's the singular of dice. It's perfectly okay to say dice for singular because people will understand you, but it's not actually correct. So that's 1/6. Other things you're going to come across when you tackle these situations are things like playing cards. Now, I don't know how much time you spent with playing cards. Have a think for a second about what a pack looks like, what's in there, and see if you can think up how you might answer a question. So there are 52 cards in a pack. 52 cards in a pack. But you won't always use the fact there are 52 as your denominator. So you could put an answer out of 52, but there's something else you need to be aware of. There are 4 different suits, they're called. Each suit has 13 cards. So if I said what is the probability of picking out the 4 of clubs, well, that's 1 out of the whole pack, so that's 1 of 52. If I said what's the probability of picking a club, you'd say that's 1 out of 4 suits. Now, each suit contains the same cards. Ace, 2, 3, 4, 5, 6, 7, 8, 9, 10. Jack, Queen, King. So there's 4 of each of these. So, 52 cards, this is 1 of them, that's 1 out of 52. Clubs, well, if I was to take the entire pack and sort them out, I'd get 4 equal stacks, so it's 1 out of 4. If I then said, what's the probability of picking a queen from the deck? How many suits are there? There are 4 suits. So how many queens are there? Well, there's 1 queen for each suit. So there are 4 queens in the pack. 4 out of 52 in total. Or, given that these are the cards and there's the same number of each, you could say it's 1 out of 13. So, some basic things there you need to know about a pack of cards. And it's really important that you are aware of those magic numbers and can do calculations quickly and sensibly. So, let's look now at a different situation. Let's look now at a football team. Now, before some of you go, he always talks about football, I want you to remember that football is played by men and women. In fact, there's a place called Lewes, which is near Brighton, which has recently made up a new rule, that it's men and women, but men, then if I say men, are paid at the same rate. Now, I hope that if you're watching this video way out, let's say in 2035, that when I say football, you don't think men, you think people. But that's a bit of an aside. So, let's take a team, let's take Liverpool. And the probability that Liverpool win a match is 0.6. Okay. What's the probability that Liverpool lose a match? Well done to those of you who've thought this through. The probability that Liverpool lose a match is not 0.4. Some of you will instinctively think, because Liverpool have got 3 options for a match. They can win, lose and draw. Now, these 3 options are the only options there are. This set of options is exhaustive and it covers all options. So they can either win, draw or lose. There's nothing else that's possible. So, it is certain that one of these 3 things happens. If it's certain, the probability of a win or a draw or a loss is 1. Because one of them has to happen if they play. Okay, so this could be 0.3. And all 3 of them add up to 1. So this last one would then be what? Well, that's 0.9. So the last one is 0.1. So the probabilities for exhaustive events add to 1. Okay, let's use this rule then. The probability it rains today is 0.2. What's the probability that there's no rain? Okay, first thing then, these two events are exhaustive. They're the only possible events. So they have to, the probabilities will add up to 1. So this one must be 0.8. Okay. So, here's a bag with some beads in it. It's got a red bead. It's got a black bead and a grey bead. So the probability of a red bead is 1/3. So the probability of the black bead must be... Well, hang on. I know it's 1/3, but why are you asking the question? Well, if the bag only had red and black in it, excuse me, this would be 2/3. Because it has another colour in it, because these two as a pair are not exhaustive, if we didn't know what was actually in here, we wouldn't be able to work this out. We do know it's 1/3 because we can see inside the bag. But if we just had a random bag, we know it's got red in it, we know it's got black in it, but we don't know if there's anything else. We can't work it out. So it's really important you check whether your events are exhaustive. So let's do 2 more questions on this to get your head into it. So first one, and this is a classic old style exam question, and then I'll do a harder one. People were asked which of these was their favourite food. And they were asked, and you were asked to calculate X, which is the probability that someone chose that type of food. Now, let's do our check. If the options are exhaustive, then the 3 numbers add up to 1. So add up the 2 we've got. Now be careful here to put them in columns. That's 0.95. So what do I add to 0.95 to make it up to 1? Well, the missing bit is 0.05. So pasta is 0.05. So I'll process again, check the events are exhaustive, then that means they add up to 1, and work out the missing number after adding these other options together. Let's have a look at the clever question. Can you work out what was asked in this questionnaire? S&V, RS, C&O, and PC. Okay, I'll give you a clue. If I was to rustle something around, you'd then know. Salt and vinegar, ready salted, cheese and onion, and the dangerous and sometimes controversial prawn cocktail. So, salt and vinegar was 26%. Ready salted was 10%. And look what happened to the last two. Okay, these were the only 4 options available, so they were exhaustive, which means they add up to 1. So the pair I've got as numbers add up to 36%, and the other pair makes 4x. Now, 36%, if I take that off 100, I'm left with 64% to find. So 64% equals 4x. So x is 16%. It's the same rule. Check they're exhaustive, then add them up to make the whole amount. So 1 or 100%, depending on how it looks. So to recap what we've done here, we looked at basic examples of how to write the fractions, which are probably the safest way. We learnt a bit about playing cards because that's really useful. We then looked at how you work out a missing option if they are exhaustive. We also looked at what happens if you don't know if they're exhaustive and you can't then work it out. We then solved a couple of examples where they've thrown a little bit of algebra here just to distract you because you know that you can work that out, and here where you actually have to form and solve a very simple equation. So you've done well here. I want to take you back to the Liverpool example for a minute and use this space down here. The probability Liverpool win or draw is what? Well, it would be 0.9. Because when I want to combine two results with or, like we did here to work out the other one, or means I have to add the two probabilities together. It's just a reminder of what we did here. It's really crucial. The probability of event A or event B is I add the two probabilities together. And we'll pick that up later when we start to combine things in complicated ways. So well done here. Difficult video, lots of content. Go back through it if you need to. And remember to pause the videos as you watch them whenever something becomes unclear.